Hello, everyone. Good morning. Congratulations on getting up early to watch this presentation. My name is Martin Devers, and so this presentation will be talking about code generators. Um, so I kind of titled this Code Generation for the Masses because my impression is that code generators can sometimes seem daunting. They seem like something which are complex to do, and so that's should be reserved to a few people who have enough time or who are very senior. And my goal is to show that it doesn't necessarily have to be this difficult, and that code generators are actually a very useful tool to have in your software development arsenal. Um, so it's worth it to take the time to understand what code generators can do for you and how to build one. So those are the two problems I'll try to tackle. What problems do we solve with code generators? When is it a good idea to use one? And how to create one. And I'll go over quite a few examples of well-known code generators to kind of get you in the feel of how they work and why they were created. Before we go into that, one more thing. You might notice in the top left, there's a short link. This is something that allows you to follow the slides. So if your resolution is bad for the stream or something like that, don't hesitate to go on that link. And that way you'll get a probably higher resolution version of the slides that'll scroll through automatically. Because it's basically rendered directly from the website. So back to the presentation. So what is a code generator? Code generator is basically something that takes, let's call it a model, which is the source of truth. It's an abstract, structured representation of what you want to generate, and then it processes that and it generates some code, and you're going to consume that code in the app. That code that is generated might be the implementation of an abstraction that's not generated. It might be a whole API, depending on the case. So the app might call the generated code directly, or it might call something from a library, which ends up calling the generated code. But in any case, the important aspects and this kind of schema that I'll always be using to represent code generators is you have the source of truth and you create generated code from that. So why would you create a code generator? Well, the first reason is just to go faster, because if you're going to be doing the same thing many, many times, and you can always just specify what the code is supposed to look like using a few parameters, you can go a whole lot faster if you have something to write it for you. So when you're developing a new feature, if you can just say like, oh, so this feature is the same as the previous one, I just need to have like this parameter, this parameter, this parameter, and then I just run the generator, then you're going to be saving a whole lot of time. You're going to be saving a lot of time during the maintenance and the evolution, because if you want, for example, to migrate all that code to a new library, well, if your code is generated, then you just change like the generator, you adapt it so that it uses a new library. If that requires some complex structural changes, you still just do that in the generator, and then boom, you just relaunch it again, and you've got something which is up to date. So having this code generator actually gives you a lot of flexibility to update the tools you're using. And in terms of testing, so this one is worth like adding a bit of nuance to, because code generators can help you also save time by not requiring you to test as much. So I'm not saying you should never test generated code, because if you're using, for example, a generator to create parsers and serializers for JSON or anything else, it's generally a good idea to have some sort of test, especially to guard against accidental refactorings. But what I'm saying is that when you use a code generator, you don't need to be as careful testing for all the edge cases and everything, because once you've tested it in one case, if you generate it for all the other cases, then it should work just fine. So you can save a lot of time also by just not having to do all this thorough checking every time you generate new code. The second big gain when you use a code generator is the consistency. So you have everything which will fit exactly the same standards. So if you've defined that things should work in a certain way in your generator, then all the things that are generated by it will work in the same way. You've got everything which is perfectly formatted at the same time. And going back to the speed of development, that's actually a huge gain, because it also means you don't have to waste time reviewing merge requests and saying, oh, this is not how we write the code, this is not how it should be formatted. The generator is always going to create it according to the standard that you defined, and it's always going to be perfectly formatted according to that standard, so you have this great consistency in the way the code is written. And it's going to be stable, because once you fix a bug in the code which is generated, it's going to be fixed everywhere. And the last one, and this is one that I'm going to emphasize, is that you can have something, you don't necessarily have it, and that depends on the source of truth. So I'll go back to all this. But using a code generator, you can have a source of truth which is platform agnostic. So basically, you're generating code from something which is not dependent on your platform. So all platforms can use that source of truth, and you can make sure that everyone is sharing the same standard. And that is extremely important. It can be extremely useful for when you're sharing specs between the server and the client, because that way you know that when you're calling the server API, you're not making a mistake in your request arguments, and you know what response arguments the server will be returning. So if you share that spec and you generate the code based on it, you know that you're both doing the same thing. And it can be useful between clients to make sure that everyone is doing exactly the same thing. So those are the sort of, to me, the three big advantages of using a code generator. And I'll be going in more details. I'll be going basically over a lot of examples of well-known code generators. I'll start off by annotation processors that are one type of code generators. And they're often when people think of code generators, they tend to think of annotation processors first. And that's only part of it. And the thing is, going back to my introduction, annotation processors tend to be pretty complicated. And that's also why I think people tend to think of code generator as something very complex. But a code generator doesn't have to be an annotation processor. So in my second part, I'll be talking about code generators that don't rely on annotations, but that rely on some sort of model file, which is in a different format. So first, Dagger. So I'm not going to go into a debate about which dependency injection framework is the best, but what does Dagger do? I imagine a lot of you are very familiar with it. You add annotations to your constructors, you add a few methods here and there to have provides, you create a component and annotate it with components, and it generates the whole, basically a dependency injection framework to resolve all the dependencies. And you can get, in this example that I showed right here, you create an instance of your app, and it'll take care of instantiating all the dependencies. So why is this such a powerful tool? Because the dependency injection code, if you had to write it yourself, which you totally can, it's really boilerplate. I mean, you have all the information on what that code is supposed to do just from the actual classes that it's calling. If you have a constructor that takes 3 parameters, you know that in order to get an instance of that class, you need to call that constructor. So why not just generate something which will call it by itself? And that's basically what it does. So it saves you a lot of time, and that's when code generators are great, because you want to have something which can be easily deduced, which requires writing a lot of boilerplate code. And it has another advantages, which is that it gives you the extra safety because it validates your dependency graph. So you have this speed because you have to write less code, and you have this consistency, this safety, because it validates everything for you. Well, second example is the Room database that we've acquired recently in our Android arsenals. Well, it's been a few years now. So Room allows you to just add annotations to some classes, and it creates a database and it binds everything together. So again, there's a lot of boilerplates to correctly do transactions in the database. Room takes care of building all that for you. It validates the schema consistency. It provides type safety. It takes care of all the queries for you. So again, you save a lot of time in writing everything, and you don't have to write all that annoying boilerplate, and you get some additional safety because it'll check that the schema matches between when you're doing your queries, your insertions, your declaration of the schema, etc. Moshi. Moshi is also a well-known one. So Moshi, just a bit of nuance, is actually, I'm talking about Moshi CodeGen. And Moshi exists in another form, which uses reflection, which does not generate code. And I'll get back to that a bit later. But Moshi, you just add some annotations on your classes, on your fields. It generates all the serialization and deserialization for basically your simple podros that represent the contents of JSON. So that's a very powerful tool. I mean, we've had this kind of thing for a while. And yeah, it's if you had to write it yourself, you could, but you'd have to write it twice, once for the serialization, once for deserialization, even though it's the same logic both times. So you save a lot of time by writing by using Moshi. And there's actually an interesting thing with this. Moshi also gives you significant performance gains compared to if you were writing yourself, because it's it's pretty annoying to write yourself a streamed implementation of a JSON parser or serializer. If you were writing it yourself, you'd probably do something where you build the JSON tree and go from there. But that's actually much slower. So you can see that actually by generating code, you can also get some significant performance gains just by being able to do things that would be very annoying and very complex to write by hand. So this is probably a bit of a lesser known library, which is called AutoValue. So what does AutoValue do? You create an abstract class like this one with just simple properties, and it will generate the factory and the implementation. And the implementation is going to automatically have the toString, the hash code, and the equals methods that are going to be generated the right way. So you might be thinking, oh, what's the point? We have data classes which do this for us. And this is kind of just, the goal is kind of just to say, yeah, and you saw that this was such a valuable feature in the code generator that eventually it became part of the language. And there's actually, if you look at propositions for the Kotlin language, you actually have some which can integrate dependency injection into the language itself also, because it's something where code generators are very useful, but it's so necessary that it could make sense to actually make it part of the language. And you also have something else which is worth thinking about. You have different versions of what you can generate along that same contract of data classes. So an alternative library is immutables. It more or less does the same thing as the AutoValue or the data classes, but in a slightly different way, because when you declare, so in this case, you're going to declare the interface, and it's going to create the builder and the implementation, which has the hash code and the toString and everything. The builder object is going to perform some additional validation. So you can see here that data classes are not the only way to solve this problem of value type. You have a few different patterns. You can use builders, you can use factory methods, you can use many different types of things. And this is an alternative. So these code generators which create value types are not necessarily completely obsolete now that data classes are here, because there are still different ways of doing things. So keep that in mind. If the compiler is generating code which doesn't really suit your need, if you think that the data classes, it doesn't match what you want, you can always use a code generator. And in this case, the nice thing about this generator is also that you can plug some serializers and deserializers into it. So now we're moving on to the generators that don't rely on annotations. These rely on an outside source file. So the first one is a protobuf. So you create the protobuf file, you describe the model, and then it'll generate the value type corresponding to that with its builder, and it'll generate all the code to be able to serialize it and deserialize it. And this is very powerful. And alternatively, you actually have a wire library, which is created by Square. So again, it does the same thing, but some people like different standards for how their value types should be generated. So they created their own version. So the power of protocol buffers is really that the whole specification is language agnostic. So you create this specification in their own language, which they designed, and you generate it for every platform, and everybody's going to be serializing and deserializing exactly the same way according to the same spec, and they're going to be communicate. So again, not only do you save this time to do serialization and deserialization like you would if you were using Moshi or something like that, but you actually have this guarantee of consistency between platforms. And that's where you see that code generators can really help you get that consistency. And we could have that also with JSON, by the way. We could totally use some sort of specification of what JSON objects could look like, but Protobuf was built with that idea in mind from the start, so it's a really good tool for it. SQLite. So SQLite, you might be thinking it kind of does the same thing as Room, and you're right. But the difference is that rather than relying on annotations, it relies on external files with the SQL statements that are used to generate the database and the and the code to access it. So again, the huge advantage is you can have something which is platform agnostic. So if you're building for several platforms, then this library will generate for each one of them based on exactly the same schema. And so you'll be sure to have consistency. Swagger CodeGen is probably something that less people are familiar with. So Swagger, also called OpenAPI, is a standard for describing a server API. So in this case, if you look at this example, we say that the path of pets, and then you put the ID of the pets. If you call that on the server with get, then it'll return a pet, essentially, if the request succeeds. And there's the parameters, so I kind of commented that part out because it's there's a lot of parameters when you describe this. But essentially, the idea of Swagger is that it allows you to entirely describe in a formal and structured way your server API. And this way, you have a very clear contract between server and clients. And they provide some code generators. So the generators themselves, honestly, are usually, I mean, it's worth spending a bit of time to tweak them or to build your own, actually, if you want to have your own formatting. But they have a generator which works for a lot of languages. And this is essentially what it would create for Kotlin. So it creates your API class, and it creates the method to call each endpoint that you declared with the arguments that were declared in the endpoints and the return type, which is based on the JSON schema, which was described in the API. So like I said, this generator actually, from having used it, it shows its limitations pretty quickly, and it's actually pretty easy to just parse the Swagger specification yourself and to create your own generator. So don't hesitate to do that. But this is a very powerful thing. And you might be thinking also, oh, I use retrofit for all my requests. What's the difference? Well, the difference is that standard. You can use retrofit. You could use retrofit with Swagger CodeGen, technically. You create your own templates that create the retrofit interfaces based on the schema. But the difference is you will know that you're consistent with the schema. So this is the sort of topography that we've created of code generators. So the ones that rely on annotations and the ones that rely on source files. So you can see some of them serve the same purpose, like Room and SQLite, that to create your database access objects. And they take a different approach. So one of them is going to try to not be dependent on the platform, and the other one is going to try to be simpler by just requiring you to write that Kotlin code with a few annotations so that it works out of the box. And as always, like I said, code generation are one tool, but there's different ways to do it. So you can see Moshi CodeGen. Well, Moshi actually exists in a reflective manner, but so does JSON also, serves the same purpose of parsing and serializing JSON without having to generate any code. So you can do it with a code generator, or you can use it at runtime. That's essentially true for a lot of these libraries that use annotation processors. Basically, if you have the annotations and you process them at compile time, you could also just keep them and use them at runtime to do the same tasks. The point of using the code generator in the annotation processor is to be able to do additional checks at the compile time, so you get more safety, which for JSON is probably not relevant, but for things like dependency injection or for databases, it's very useful. And it also gives you generally a better performance by having that code which is already generated and avoiding the extra cost of reflection. And you can also, like I've said, like you can see that retrofit is also a different approach to Swagger CodeGen, which is actually it's not necessarily one or the other. You could use Swagger CodeGen to generate the retrofit interfaces, like I've said. But yeah, the point is just that you have these code generators that are tools from a set, and you can choose to use them. But the huge advantages to me of building your own code generator, they come when you start doing these. When you start using these platform agnostic specifications, where you can generate code for all platforms, which fits the same standard. So now we're going to be going into how do we create a code generator. So as often, I'm going to start off with a hello world, which, as all hello worlds, is going to be pretty useless. If you want to generate code, you can do it in any way you want. Any software which writes code, which can be run by another piece of software, is a code generator. So in this case, if I just create a bash script which writes a main function to another file, then I have my code generator. And this is what the generated code looks like. So like I said, it's completely useless. And more importantly, it doesn't have any model that it's consuming. So it doesn't fully illustrate my point. But here's a bit more complex of an example that we've actually used ourselves. If you're curious about the background, there's the list of top-level domains that are referenced on the internet. And we want to try to check, well, we can't check for sure, but we want to try to guess when we have a string which looks like a domain, whether it actually is a domain. And one of the ways to guess that is whether the top level domain is one which is officially referenced. Because if it's not, then you're pretty sure that this is not referenced, so that this can't be reached from like the public internet. So there were several ways to do this. We could have just downloaded the file with the list of top level domains, and we could have shipped that as a resource, but we prefer to have it as a list so that it could be loaded faster. So we had this code generator. It performs this curl request to download the model, which is just that file with one line per top level domain. And it just performs this kind of this little sed to transform it into a static list, and that way we can ship that list in the app. So this is a code generator, a pretty simple one, but fairly effective. And whenever you run it, you get the latest version of the list, and this is what it looks like. You just have this simple file. So you can see code generators don't have to rely on your own specification. They can consume something from the outside as long as it's structured enough so that you can parse it, you can understand it reliably. And this, by using this code generator, we have something which is in our own format that we control, and which has some performance gains by not having to load a resource, and which can easily be maintained up to date with the latest standard. So if you want to create something more complex than just a static list, you're going to have to look for more powerful tools. So the well-known one is Kotlin Poet. So it replaced, well, it didn't replace technically, but it works the same as Java Poet, which was the same thing to generate Java code. What it does essentially is it allows you to describe sort of a simplified abstract tree. So you declare the files that you want to generate, declare the types that you want to add in them, the methods and everything. You write the statements, and the nice thing about it is that if your logic is pretty complex, it takes care of all like the handling the imports of the types, some things in formatting. So it's pretty neat. I think it's well suited to when you're building an annotation processor, because annotation processors have to consume code from the project that they're processing. So a lot of different types that might be complex to handle. In my experience, it can be a bit of a handful to master right at the get-go. So it can be a bit too powerful of a tool to start off with if you just want to write a simple code generator. But it's a very powerful tool when you want to just have something which scales indefinitely. But when you're starting off, and this is basically so what it would generate. So you can see it's, you have to write quite a bit of stuff just to generate this small snippet. But another approach, which in my experience works pretty well, is to just use template engines. So I started off with this template engine as an example because it's the one which the Swagger CodeGen library uses. which is called So this is called Mustache. It's more popular with JS engines. So there's a lot of tooling to use this format in JS. So it might not be the best suited one for your code generator, actually, if you're writing that in Kotlin. But yeah, it turns out that the Swagger code gen tool is written in JS, so they use this. And it's a pretty straightforward format, as you can see. So you have sort of this this value object, which is passed to the templates, which has these properties like the class name, the base path, etc. And you write this template and it'll generate the whole thing. So that's why it's actually fairly easy to take the Swagger code gen tool and to customize it by adding some extra, like by adding some different formatting or some different standards. But yeah, you don't necessarily control the value object which is passed and all the properties it has. So you can see some limitations there. So another template engine is FreeMarker, which on the other hand is built more for the Java ecosystem. So in my experience, it's a pretty good choice if you're building your code generator in Kotlin and you want to use templates. So the nice thing about using templates, like I said, is that you control the formatting entirely yourself. So if you have your standards for how your company wants to format the code, you can totally apply them. If you want this, in this case, to have things formatted in a certain way because it makes sense to make the code readable, you totally control it. And just always keep in mind, no matter what, that's the format of generated code is very important. You should always be able to read the generated code. Don't assume that just because it's something that you're not writing by hand, it's okay to have it completely messy and unreadable, because you will at some point want to try to understand what's going on. You will have to debug through it. So yeah, keep it tidy. And so this is the example of what we've actually done, because we use Swagger to create the spec for our API, but we don't use Swagger CodeGen because we had some complex. We have some authentication methods that we wanted to handle specifically, and that were a bit tricky. That's also why we don't use retrofit, because we could have plugged it in, but it was a bit of it would have required jumping through hoops and doing some weird stuff. So we don't use retrofits to do a network request. We just actually generate the code which executes it every time. And this is a very simplified version of what our template looks like, which generates the API calls. So today, what that means is that whenever the server team generates a new endpoint for us, they publish it. We have this sort of little configuration file where we say these are the endpoints that we want to generate, because we don't consume the whole API, so we don't generate the whole thing. So we just add the description of the endpoint that we want to consume, and then it gets generated and we have it available for our app. So it saves us a lot of time, because like I said, everything, like no review of the generated code, we don't really care. We don't have to look for issues, for any potential bugs. We don't have to write tests every time to make sure we're doing things correctly. It just works out of the box. You just add the path, and there it is. You're good to go. So essentially, when you're building your code generator, these are all the steps you have to go through. You have to define the syntax of your model. So if there's one which is already defined, like Swagger, it's probably a good idea to use that. I have to emphasize, be rigorous when you're describing the syntax. A lot of the time, the simplest thing is to just use JSON rather than trying to define your own DSL or something like that. I mean, if you're Google and you're creating protobuf, you can afford to do that and create your own language. But generally, yeah, just describing how your JSON. Just describing describing the JSON structure of your model is enough. But make sure you're very rigorous, that you have a strict JSON schema describing what your model should look like. Typically, be careful, because if you're transforming the keys of the JSON into the names of fields, you probably want to put a regular expression so that people don't put spaces in the keys or anything like that. Otherwise, your generator, you're going to have to add some extra like formatting, some to make sure that it works correctly. So yeah, be rigorous in defining your model syntax, so that everyone can contribute, but without risking to break anything. Then you have to generate the parser. So basically, the parser is going to take your model file and generate some objects to represent your model. And from that, you can create your generator. So like I said, to start off, it's generally a good idea to use this type of templating tool. You can also, if it's really a pretty simple, if you're generating pretty simple code, you can actually just write to the output stream, like directly into the files. But that won't scale very well if you start having more complex structures. And it'll be a big hassle to maintain really quickly. So I would not recommend sticking with that for a long time. But yeah, so you write your generator, which is going to process the model and create the code files. And there you go. Basically, you just have to decide how that generated code is going to be consumed. Usually, I think it's a good idea to have separate projects or at least separate modules where you have the generated code so that it doesn't get mixed in with everything else. And the last step is to think about the continuous integration that you'll have. So how are you going to make sure that you stay up to date with the model? So this is probably not the thing that you think of at first. It's not necessarily critical to getting everything to work. But typically, if you take the example of the top level domain list that I showed, how are you going to make sure that you stay up to date? Because you can't subscribe to updates or anything like that. So in that case, you'll probably want to have like a periodic runner, which every day at midnight runs and downloads the latest version of the list and generates it. But if you're maintaining the repository with the specification and the model yourself, then you can probably have something like where you subscribe to that repository with a spec, and whenever there's a change in it, you run your CI. I've got something telling me that I'm running short on time, so I'll wrap this up. This is typically when we have a dedicated project for generation, this is typically what it'll look like. So you'll have one module with a generator. To make things simpler, what the file that I call definition.json would be the specification. So we would just pull that from the central place where it's stored and put that directly in the resources of the generator project. That way you can run your generator code. It's going to load the template file also, which is a free marker in this case, and it'll generate the code in the other project, in the other module, and that'll get published as an artifact somewhere that we can consume in our main project. This is just kind of the rough idea that we've used for all our code generation projects, but it works pretty well for us. I think it's a sound way to start off. And just a reminder, so this is a very rigorous graph based on scientific data, as you can imagine, but the idea is the yellow chart is the amount of effort you'll have to put in to build the code generator, and the blue is if you don't. So the point I'm trying to make is just the code generator probably won't pay off right away, because at the time when you write it, you'll probably already have a lot of the code which is written, and you'll probably not see all the stuff that'll be used for. But you have to make the case that in the long run, it always ends up paying off. For all the reasons I've said, you get better stability, you get better development speed. So in the long run, you'll just be spending less time to write this boring, repetitive code if you create a generator for it. So I'm not going to lie, you have to put the effort up front. Building the code generator will take a bit of time, but just always keep in mind the payoff is in the long run. So just to conclude, just this little exhibit quote, I heard you like code, so I wrote you some code which generates some code that you can use directly in your code. And that's all. Thank you for your attention. I'll be looking at questions now. And I don't see any questions. I can't read them. How do I make this bigger? There you go. Any thoughts about the upcoming KSP? No, not particularly. No, I think the KSP is the Kotlin. It helps you build basically compiler plugins with that are sort of like annotation processors, if I'm not mistaken. But like I said, my focus on this in this talk wasn't so much about annotation processors. Annotation processors are a complex tool. They're really powerful if you are making like a general library, but if you want to generate some code for your business needs, you probably want to stick with something which just uses a model file. It'll be easier to consume and probably more flexible for your needs. And I think the second question is kind of the same one. And any tips to avoid the build time introduced by code generation? Well, again, I think there's a bit of confusion because I'm talking about code generation in general and not annotation processors specifically. So a lot of the time when people complain about build times, it's because annotation processors run during the build and they have to generate all that code. So that's not specifically the topic. That being said, there are some things that can be said about how using code generators does add another layer to your entire build process, because you have to take the source of truth, the model, no matter what that is, even if it's an external file, and you have to compile it and build it into a project. So that means, take for example, you have this spec which is shared by all platforms, and you want to update it because you need to use a new version in your project. Well, you will probably need to make the change in the spec repository. If you've got your whole CI set up properly, once that's merged, it'll trigger the CI in your generator module, which will generate a new version of that module. And then you'll be able to use that new version in the main project. So there's definitely, as you can see, like there's a bit more of an overhead in that whole pipeline. Ultimately, I think you just have to see that the gains in terms of everything I've mentioned, the consistency and the reliability of the code, they outweigh whatever drawbacks there may be. Do you have any resources we can use to get started? Not particularly. Honestly, I would say just start small. Start with something very simple where you just have this very simple model that you use and write this really basic code generator, which, consumes that model, generates a simple model classes. Another example that I didn't mention is we use code generator also for the user data, because at Dashlane we make a password generator. This means all the user data is encrypted when it goes through our servers. We never want to have access to user data, so it's entirely encrypted with their master password. The thing that becomes difficult with this is that the server can't perform any validation of the data that clients send to them. So it's paramount that clients all use the same standard, that they're all using exactly the same value and the same types for the same for given keys when they serialize the data and encrypt it. Otherwise, you sync on one client and you go to another and you don't see the same data. So we use code generators for this to have this exact spec, and it's fairly simple because you're basically just generating the data types like what I've shown with auto value and with immutables. But it's very important that you do that with the serialization and deserialization that works correctly. So that type of thing is a good place to start. I think just having data types that are following exactly the same standard when you're exchanging them between server and client or between different clients, that's a very good application for a code generator where you have this shared standard. Let me see. Do you know any good way to generate multi-platform code? Depends whether you mean. Do you mean like generating Kotlin multi-platform, or just generating codes for different platforms using a code generator? If you're using a code generator, that's a very good application for a code generator, because you can essentially you have your model and you can generate things for different languages. So each platform can create their own generator, or you can have just different templates for each platform that could actually save you some time, because then you share the whole part with a parser. But yeah, having a code generator is actually a very good way to solve that problem. All right, my time is up. So thanks everyone for your attention. I hope I answered some of your questions. I feel like some people were hoping to get more on annotation processors, but that wasn't really the focus. The idea was really to show that you can do a lot with code generators, and that you don't have to build an annotation processor. That was actually one of the big takeaways that I was hoping you'd get, which is that annotation processors are more complicated than code generators, and so you don't have to think annotation processor to generate some code. And by using a generator which is not an annotation processor, but which relies on a platform agnostic spec, you can actually gain a lot. You have something which is consistent between platforms, and that's something which is very valuable in the long run, and which gives you a lot of safety. So that's all. Thank you everyone for your attention, and enjoy the rest of the conference.